Hello students, I'm back again with the same chapter, Object-Oriented Programming Concepts in Java, Part 2. In this section, we will be learning more about the object-oriented programming. So, let's start. Here we will learn the object-oriented programming in detail. First, we will learn that there are some principles of object-oriented programming, which are the key points to use the OOP. What are those? Let's see. These four are the principles: data abstraction, encapsulation, inheritance, polymorphism. Now, let's go in detail. Here we will learn data abstraction. Data abstraction is basically hiding the data from outside world. First we will see what are the points, then I will explain you. It is the act of representing the essential information without knowing the background details. That means while doing something, if you are representing the only essential information to the outside world and hiding the background details, then it is data abstraction. And the measurement of how much information is essential is relative to the purpose of user always. Now, let's explain this with an example. See, in this ATM, when we use the ATM card, we know how to operate the ATM card with how to operate the ATM with the ATM card. Now, what buttons to be clicked, how the money will come out, how the slip will come out, everything we know. But do we know what is exactly going inside the ATM machine, or what is exactly going on background of that system? No, it is not disclosed to us. That means the amount of information we should know, only that part is disclosed. That means what is disclosed? How to operate the ATM, how to collect the money, how to update your balance, how to see your balance, how to get the updated slip. And only this part is disclosed with the ATM card and ATM machine. That means what is going on at the background of this system, we never know. We are outside world. That is known by the developers and the system maintainers who are maintaining that system. So we are the outsider world. We don't know what is going on exactly behind the ATM machine or inside the ATM machine or behind the system. Now see, here we are the outside world. Now, one more explanation I will give, that while using the remote of a AC or television, we know only the buttons. We don't know what is going on exactly inside it. What is the functions? We don't know. So now we will proceed to the next principle, encapsulation. Encapsulation means enclosing something in a capsule. And in this case, it is wrapping up of data and functions in a single unit. And this wrapping up of data is known as encapsulation. Let's see the example. See, this is a capsule, medical capsule. Inside the capsule, so many compositions are there. Those compositions are not disclosed to the outside world. So the all compositions we need for a particular disease is included inside that capsule. That means the capsule is actually the class, and the beads or the composition beads inside the capsule is considered as methods and data or variable. So this is how the object-oriented programming emphasize the encapsulation in data. It is also the hiding of data from outside world. Now inheritance. Inheritance is a very interesting principle. Suppose we all get some of the characteristics in us from our parents. That means we got some characteristics from parents as well as some of our own. So this concept is actually in object-oriented programming inheritance. What is that? If a new class is created with all or some properties of an old class, then this mechanism is inheritance. The new class is actually the child class, and the old class from which we are acquiring the properties are called the parent class. Now, inheritance represents an either relationship, and it is a parent-child relationship. That means from parent some or all the properties we get, and our parent got their some properties from their parent. So this is like exchanging the characteristics from one generation to another generation, but in this case it is not generation, it is class. From one class to another class, some common properties are shared. Now let's see the example. Here vehicle is a class. Vehicle means the vehicle which can move, the transport which can move, some vehicle which can move, which has some mode of moving like wheels and so like this. Now vehicles can have some properties. Now bike is having all the properties of vehicle along with some new properties, as well as car is also having some or all properties of vehicle along with its own properties. So here the vehicle is the old class and parent class, bike and car is the child class. You can see the vehicle is the parent class and bike is the child class. Car is also child class. Here we will see the class structure. Vehicle class is having the ID. A vehicle should have ID, name and a license number. All the vehicles we have license number. Now two-wheeler, that means the bike. I am considering bike. Two-wheeler can be any, scooty also, cycle also, but in cycle we don't have license number. So two-wheeler have ID, name, license number, all the properties of vehicle class along with the new property steering handle. So it is a new class with all the properties of its parent class. Now four-wheeler. Four-wheeler is also having all the properties of vehicle class with the new steering wheel. That means two different new class is made with different new properties. So this concept as a whole is inheritance. Now polymorphism. Polymorphism. Poly means many. Morph means forms. So, in short, many forms. When one code can be used as many forms, then we can consider it polymorphism. Like, suppose a container. Container is a common thing, but a container can be used to keep solid food. A container can be used to keep liquid food. A container can be used to keep semi-liquid food. That means one container can be used in many forms. So this can be the example of polymorphism. Now, polymorphism is done in Java by overloading the method and overriding the method. This we will learn in next sections, but the name should be known. Method overloading and method overriding are the polymorphism techniques in Java. So, here we will get some example. I have given some real life example. Here is a class example. Here is the shape. Shape, any shape have some area. Now, this area concept can be used for circle area, for triangle area, for rectangle area. That means area is common. The shapes are different. So a common area can be used for finding circle area, for finding triangle area and rectangle area. So different forms are there of area. So this is the technique of polymorphism. So once again I am telling, polymorphism is the using of one particular thing in many form. In this case, using of one method or code in many forms is called polymorphism. So, in short, object-oriented programming have the four important principles: data abstraction, encapsulation, inheritance and polymorphism. So, here are some practice questions which will help you for further practice. Thank you and have a nice day.